Hello, everyone. This is Belinda Carr, and you're listening to my podcast on building science, products, and technology. As we know, the construction industry is ripe for automation and disruption. It has been reliant on manual labor and outdated tech for far too long, which has led to lagging productivity. Every week, I chat with a company that is exploring ways to tackle these issues. Today, I'm speaking with Kevin Albert, founder and CEO of Canvas Construction in San Francisco. Thanks for joining us, Kevin.
Yeah, thanks for having me, Belinda.
So I guess we need an elevator pitch for your company so people know what Canvas Construction is about. And y'all are developing a drywall finishing robot.
That's right. We've developed basically a new class of tool that in the hands of workers can deliver drywall finish at the highest quality and at higher productions than have been possible kind of with manual tools.
And this is fascinating to me because my husband and I were working on renovating our 1970s home right now. And we have both spent hours and hours trying to level out bumpy walls and mudding and sanding and texturing. It's such a labor-intensive and frustrating process. But at the same time, there's an art to it. Going through this process has made me appreciate drywallers, the professional drywallers. So I'm curious to learn about how you all developed this robot. But let's go back to the beginning. You come from a robotics field, and you have a very fascinating background that I'm interested in learning more about, and especially your time at Boston Robotics.
Yeah, no, absolutely. I've spent my career focusing on machines and robotics and how can we create machines that can come out of the factory and help us in the real world. And the thing that's always really fascinated me about machines and robotics and what led me to this field is their ability to give us capabilities we didn't already have. You think about we used to, you walk places and someone invents a bicycle and all of a sudden the range at which you can get to and what you can do with your body and the capabilities that you have are so much more. The automobile did the same thing. We can go over this countless times. Robotics for me represents that opportunity to just give people skills and capabilities that otherwise just weren't even possible.
So how did you get into what did you develop at Boston Robotics, and what lessons did you learn over there? Because we've all seen the dancing robots on YouTube. Those videos go viral every couple of months, but I'm sure there was a lot of research and development that went into those robots.
Yeah, no, absolutely. A huge amount of work goes into developing a robotic system. They're incredibly sophisticated systems that bring a lot of different fields together, from software to mechanical engineering to also encompass all kinds of systems out on kind of with the customer in the application. But one of the big things we learned there, at least I took away from that experience, I was part of the team developing the algorithms that made Big Dog and the walking dog robots able to navigate and walk over rough terrain. And so really a lot of understanding of how do you deal with a dynamic, ever-changing world. And so learned a lot about how do you make robots handle uncertainty, which, the construction site is,
Full of that.
Full of uncertainty. That's right, especially compared to the manufacturing floor. So that was one of the big takeaways, and how important it was to test and get things out into the world and just make mistakes and have it fall over and try again. And it was very interesting when we were working on those, is as you were working on a new walking algorithm, it was very similar to seeing my own 7-year-old walk for the first time. What happened with him is he took one step and he fell over, and he took one step and he fell over, and took one step and he fell over, and then he took 2 steps, and then he got back up and he did 30 steps. And it was kind of the same way with those machines, and it was just this continuing to test and iterate in the world and let the real world teach you what's not working, and then once it comes together, it really just starts going and it starts working, and it was really exciting. So that was one of the big things that I always took away, is you really need to get machines into the hands of people that are going to use them and just find out
whether it works or not, and then
whether it works or not, and learn from every single experience to get to where it needs to go.
That's a good point, because we can work on things in a little bubble and theorize it all day long, but put it out in the real world into the hands of humans, are on job sites, and that's when the real testing starts.
Yeah, yeah, absolutely. And I think the other thing we learned from that experience that we've really taken to heart at Canvas is that there's just so many corner cases and, things that get thrown out at you and variability
that you
in
didn't
the real
foresee
world.
before.
Yeah, and no matter, how much you work on something, having a person in the loop, so having a machine paired with a worker, a machine paired with an operator, takes the powers of both sides, and that the technology actually can be suited to how do you enable a person to better tell this thing what to do, to better use its capabilities, is really kind of the goal at the end of the day. And that's the more powerful system for getting machines into uncertain environments. And so that's something we've really focused on at Canvas.
So when you decided to start Canvas back in 2017, how and why did you identify drywall finishing as the one thing that you wanted to tackle?
Yeah, no, it's a great question. We were always really focused on construction. Construction is mobilized manufacturing for the most part, and a lot of our backgrounds come from robotics and manufacturing. And so we were looking in construction for a couple of different factors. We're always looking for kind of the 3Ds of the dirty, the dull, and the dangerous, because those are areas where people want machines to kind of alleviate some of those pains. The second thing we looked at were things that just hadn't changed in a long time and were extremely labor intensive still. And I think, like you said at the beginning, drywall finishing is an art, and it's beautiful what we do, but just the process of it, you have to touch every wall 5 days to get, a square foot of wall finished. It's not an efficient process, even though it is an art. And so that's another thing we kind of looked for. And then the third thing is we did look for certain conditions, something that repeated itself over and over and over again. We see drywall in residential buildings, we see them in commercial buildings, institutional. It's kind of a staple, and we see it globally as well. The other thing is it's on the interior of the building. And so, it's not subject to kind of rain and other things that are going to, make it very difficult to deploy a robot. Much of it is very accessible to kind of a ground floor where you can move a machine. So we looked at a lot of different factors. And, the last one, we really, again, going back to the pain, one thing that just really jumped out at us is 1 out of every 4 finishers ends their career with either a musculoskeletal injury from shoulders or rotator cuffs or things, or from, backs from falling and things like that. And that's a really high ratio. And so looking at a place where we could really kind of alleviate not only kind of commercial pain, but really human pain as well.
Wow, I didn't know about that stat. But so you have an image of your robot in the background over there. How many iterations did you all go through to get to that particular point?
Yeah, I mean, it's funny because you can think of major iterations and minor iterations. So this is our generation 2 machine. We had kind of an alpha and a beta that we produced before we produced our first generation of production machine. And now this is on our second generation of production machine. So we've learned quite a bit as we've kind of iterated to ensure that there's a machine that really kind of like can produce value for the customers. But kind of in between all those, there's just a million different iteration cycles of throwing it out on site, finding out what doesn't work, changing the code, changing how the user interface works, changing the process. One of the big things we do is we deal with materials and how they're applied. So thinking about that process, how much water to put in, all of those things come into all of the many iterations we've done on the machine, on the system.
So let's dive into the specifics of the machine. So humans put up the drywall, whether it's on steel studs or wood studs, and then the machine is brought in. And what are the steps that it goes through before it even starts spraying drywall finishing on it?
Yeah, absolutely. Well, maybe it's good to rewind a little bit and let the audience know a little bit about what the process of drywall finishing looks like manually, so they can have that in context. So I mentioned before, it's a multiple step process. Drywall finish is the step to take, once you hang the boards of drywall up, that's your fireproofing in your wall, you have a panelized and uneven system. And so drywall finishing is a process of putting joint compound, or what's called mud in the industry, over the seams and over the wall to make it basically look like a flat surface. Once you get that done, then you'll prime it and paint it. So it's really the thing that comes before you prime and paint. And it's a 5 to 7 day process, because what you need to do, you're really frosting a cake. If you think about it, you're putting fire tape over the seams with mud on them, and then you're letting that dry overnight. And then you're putting more mud on that and kind of spreading out, or what's called feathering, to slowly spread out that seam so that it looks continuous on the wall.
Yeah.
And so you do that multiple days in a row. You do a topping coat on day 2, you widen that coat on day 3, and then you do a finish coat day 4, and then on day 5 you're going to sand back. And every day you're going to have a drying cycle in between. And so that's why it has to take, all these steps take multiple days. And if you want to get to the really high quality, then you take another day or 2, and you cover the entire surface with joint compound.
Skim coat the entire wall to get a perfectly level 5 finish or something.
Exactly. That's the level 5. So what we've done with our machine is we said, okay, how can we use the new capabilities, the accuracy, the ability to measure, the consistency and precision with which it applies material, to rethink this process. And so, the fire tape on day 1 is put on manually. And then the machine will be brought in that same day, and it will scan the interior of the building in real time and get you a geometrically accurate map, so that you are now calibrated to your space, kind of like you are in a manufacturing facility. And that allows you to apply materials very accurately. And so we map out all of the seams, we map out outlets, we map out workspaces, and then the worker can instruct the machine to apply the compound over the surface of the wall. And what we do is, on that same first day, we apply a very even layer of compound that's profiled to get you the right result. And we put all of that mud on day 1. And then
before we continue with the mud, the scanning is all done with the 3D scanner, I assume, and then it creates a picture.
Exactly. We have a suite of sensors, cameras, lasers, LiDARs, things like that allow us to capture the building with good accuracy and relative to where the machine is.
So even bump outs in the wall, and like once you tape a certain joint, it measures how far that joint is compared to the rest of the wall.
So we do have sensors that do that. They're not actually part of the closed loop process that we run for the wall, but that enables us to do other things like quality control. But for our process, we don't need that level of accuracy.
Got it. Okay. Okay, so we can, sorry, I didn't mean to interrupt you, but we can continue.
Absolutely. No, it's always interesting to kind of like dig into the pieces that enable it. Because I think that is really one of the core enablers, is like this ability to understand your world that you're in for the machine, and allow the worker to then direct the machine to perform in it, is really a lot of the core of what Canvas has brought here. So now we've applied all the compounds in day 1, and then it dries overnight to the 1 drying cycle now, and then we sand it on day 2, and we can put a sanding head on the machine, or it can be sanded by hand with a vacuum capture sander manually, and then you're done. That's it. 2 days. So we've taken this 5-day process and shrunk it down to 2 days, and that kind of goes with what I talked about at the beginning, is by using the capabilities of the machine, we've reduced the schedule that it takes to do something. We keep the worker in the loop the whole time. So we really have a model that's a lot closer to when the excavator was invented. You used to dig holes with a shovel. Now someone invents an excavator, the workers drive that excavator, a huge amount of productivity increase, safety increase, all of those things. Similar thing for us. Everything used to be done with a trowel and a sander. Now we introduce this piece of equipment. Workers drive that, and we can really truncate schedule and bring a whole bunch of leverage to create better project outcomes.
I don't want to ask you the same question twice, but I'm still trying to wrap my head around this. So when people put up studs, whether it's wood studs or metal studs, they're never perfectly aligned, because there's some variation in the wood. It warps, it twists, or even with metal studs too. I mean, there's less of a variation, but still it happens. So if a wall isn't perfectly straight, how are y'all able to straighten it in 1 day? Because like when we deal with that at home, it takes us a week because it's layer upon layer. It's 20-minute or 45-minute mud. You have to wait for that first coat to dry before you examine it and then put on another layer and then get it perfectly smooth. How are you able to level that out in just a day?
Yeah, no, it sounds like you've definitely experienced some of the pain of finishing. So that always makes it a great conversation. Again, going back to the process, we do it a different way. And so when we apply compound, we apply a profile of compound over the joint that is a little bit heavier. And so that gives you a little bit more flexibility and robustness so that when you sand it back, maybe in certain areas that weren't perfectly flat, you sand back a little bit more. And so you're not solving the problem with the iterative compound application. You can do and it really requires you to apply that compound in the right profile very accurately with the right tolerances. And that's what machines are very good at. And so that's kind of where it goes back to the capabilities and skills, so to speak, of the machine in the worker's hands enables this completely different way of doing it.
So you not necessarily level out the wall by applying mud, but you could level it out later on in the process by sanding.
Correct.
Possibly.
Yeah.
Okay. That's interesting. That's pretty interesting. Do you all have to, you can't use just regular drywall mud? Do you have a special formula that you use that is fast setting, or it's just straight off the shelves?
So we use straight off the shelves. Everything we actually attach to the robot to apply materials to sand and things like that are off the shelf. So we're actually not changing anything about what you're putting on the wall and the finish you have at home. Like, and that's one of the beauties of it, is that means that anybody who's thinking about using this machine to do the work, they don't have to consider whether like, oh, is this mud as good as the mud I use or anything like that. We can deliver exactly what they're looking for and just do it in, a much better way.
Wow. So let's talk about some constraints of the robot, because it seems wonderful right now. And I'm wondering if we can bring this to my home because I'm tired of dealing with drywall. But the machine is quite large. It does have some size constraints and it can't get into really tight spaces. Are you looking to size it down, or because you all are mainly tackling commercial applications where spaces are larger, there's more room to move around, you all aren't trying to size it down just yet?
So we do have ambitions to size it down, and there's an opportunity to get it into so many more people's hands by doing that. But where we start is with the larger commercial projects, large amounts of volume of drywall. We can get into smaller spaces in those projects, but generally that's kind of the first iteration in our go-to-market. And then you'll see us look to both bigger and smaller. One thing that's going to be exciting is when you can adapt the system to 40-foot walls, right? That's a real pain point for people to do because you're just up on scaffolding and things. Same thing for you at home, a smaller system that maybe doesn't need to go over 8 feet we can all get in our homes and do it. Is an opportunity we're really excited about. So the way we think about it is a lot of what we have actually can be adapted to different size platforms. Right now, we just run it on one that is really well suited to commercial construction.
You mentioned earlier about there is a sander attached to the robot, and it is attached to a vacuum too. And that's a very important point, because sanding drywall is a messy and also toxic process, because all that particulate matter can get stuck in your lungs. Like, I wear a respirator, but I can still feel myself like choked up by the end of the day once I'm done sanding drywall.
Yeah, no, it's absolutely true. And that's one of the things people have been extremely excited from just the very beginning. They saw the sanding and they were like, that's amazing. People don't like sanding. And being able to capture that dust particulate, like you said, it can get into the lungs. And you'll see pictures of people when they finish a drywall job just covered with dust. It's like the wall snowed on them. Yeah. Those are working conditions that I think is one of the big opportunities. We can improve the site, we can improve the job for people. And it's really astonishing to see the machine. It captures 99% of the dust. Like, it is basically a completely clean site. Air is crystal clear. You can be right up against next to it sanding, and because the machine holds the sander so steady against the surface, it really doesn't let any dust escape.
So how does the machine know that one part needs to be sanded more than the other? Is that all automated too? Because you did talk about a person coming back in after the second day and sanding it manually. Like because we said some parts of the wall might bump out and might be indented and all that stuff. So does the machine account for all those bump outs during the sanding, or
So
is it just a single pass?
Yeah, so we do capture a lot. We do capture a lot and reduce it quite a bit. But the machine there's no job the machine's going to capture everything. And so that's part of our model, actually. And so everything we do is really looking at how can we take 70%, 80% of the burden off of folks, but still that keeps them in control of the final finish. And so for any of those pieces, we can always have the workers in control of the site, directing what's going on, making sure there's a great final finish. The machine can measure that, and that's part of the beauty of the process, because we've been able to take days out of it. It enables us to do that. It enables us to kind of keep that collaborative nature of it.
So you said that the machine reaches a level 4 finish of drywall, but why isn't a level 5 finish? Is that something you're hoping to get to eventually?
So we do both, actually. And this is a recent launch that we just did. So it's very exciting. Our machine, it's all a software change. We can deliver level 4 or level 5 finish in 2 days. The level 4 happens much more quickly. From a labor standpoint, and so that alleviates production rates if level 5 hasn't been spec'd. But we can also deliver level 5, and the level 5 we deliver is all the contractors we've worked with have just talked about the quality that it delivers.
So how's the reception been? Y'all are based in San Francisco, but the projects that you've worked on, are they just in California, or have you been working on projects around the States?
Yeah, so far we stayed in California, and focused really on a lot of refinement. We have a number of partners here in the state of California that are great, that have been really involved from the beginning and focused on moving the industry forward. Folks like Neville, Daly's Drywall, Swinnerton, DPR, these Webcore, these types of companies. And so we've been working really closely with them. And like I said, that test and iteration process, we did that with them, a couple of years ago to make sure the machine was right. And so we're now starting to deploy outside of the California area, and deliver machines more broadly to customers.
So the feedback that you've received from clients and from customers, what sort of budget cuts have they told you about? Because not budget cuts, I mean, how much money do you think they told you they have saved because they've used your drywall finishing robot?
Yeah, I mean, we don't really talk about that as much. I mean, we definitely deliver a bunch of value, but a lot of the focus right now in the industry is finding the workers that are needed to do the job. We have to build twice as much over the next 40 years, and we have a growing labor shortage that there's multiple factors, but the strongest factor is just demographics, right? Like the baby boomers are retiring. The average construction age is, in the 50s, and we're just not bringing people into the industry fast enough because there aren't enough people to bring in that quickly, among other reasons. And so that's a lot of what our customers really focus on is they're asking, how can they get a competitive advantage for this future that is going to be even more labor constrained than it is today? And so we really focus on that. And then as you look further up the chain, right, the general contractor and the owner care about getting that project done faster. They care about schedules. They care about reducing financial risk from both labor and schedule. And so by enabling them to do their jobs faster, that enables our customers to win more work, and kind of have a competitive advantage. And so we've seen those things really drive our business a lot. and a huge amount of excitement for giving people better tools.
So do you all sell the robot, or do you all lease the robot to different clients and customers?
Yeah, so we lease the robot to customers. We have an enterprise leasing program where our customers will take machines on, and this enables them to have guaranteed access to the system. And usually they, kind of move it from project to project, and kind of use the system, a predominant amount of the year.
Do parts of the machines get run down because it is used so heavily out on job sites?
Oh yeah, you're talking about what's the durability of the system, and so that's one of the interesting things is we've built it around construction hardware like a JLG lift, which is kind of a person lift. The robotic systems that we use come from manufacturing with 10-year lifetimes that are supposed to be used 24 hours a day type of thing. So a lot of the hardware and equipment that we've made our system out of all just are designed to be
beaten up on job
beaten
sites
and used day after day after day. So we actually don't see that problem. For us, it's the challenge of our business is continuing to enhance the software and continue to handle more cases, and enable workers on more things, like we talked about earlier with getting into residential, and handling a new set of walls.
That's very interesting. So it's kind of like a Tesla. There are some similarities to that. You all can continue improving the machine by making software updates, and the client doesn't have to go and purchase or lease out a new machine. They're going to see those updates because it's been integrated into the machine that they already have.
That's exactly right. Yeah,
that's interesting.
Yeah.
Okay.
That gets into, it's the power of the digital tool, right? We talk probably a lot about data and site coordination, but the over-the-air update and upgrading your tool along the way is one that probably isn't talked about as much, but is going to be kind of a big part of the future of construction in a lot of industries.
So it seems like an awesome robot. It has so much potential, and it's definitely needed in the construction industry. But I'm sure the path to get to this version 2 of your robot hasn't been easy. There's been lots of ups and downs, lots of learning going on. What are some memorable things that you have learned through this process?
Oh man, so many. I think certainly there's a ton on the technical side, but some of the most interesting things for me have been learning how to work with our partners, and enable them with the system. And that's not just saying like, hey, here's a system that works and it can deliver materials or whatever. Understanding the whole ecosystem of the construction site, and enabling not just the person who's using the machine, but working with the foreman and the superintendent to understand how they're running the job, the things that they're doing to enable this machine to work on site. Because one thing we do is we change how fast you get a set of walls done. So that changes how you might run a site, right? Like you might be thinking traditionally, okay, I'm going to run through this thing and my person's going to touch every wall once every 5 days, and that's how I'll deploy my crew. And for us, it's like, no, you don't touch that wall 5 days. So you might sequence it, completely differently. And that there's a lot of benefits to that, but there's also a lot of learning, and working with the superintendent and the foreman to understand how to do that, understand, the communication flows on site so that everybody on site can understand that this thing is coming, and that it's going to work and what to expect. And so that's been one of the really interesting things that has been probably one of the biggest learning curves for us, is that coordination and kind of working with the whole ecosystem while we're out there.
So that ties into my next question about completely eliminating people on job sites. And you have, throughout our talk, you've always said that humans are still involved in the running of this machine. They're still monitoring the process. They come back and finish the drywall, the very last stages of the drywall finishing process. They're not completely eliminated. There's still a need for humans on job sites.
Yes, that's correct. And this is the classic robots and jobs question that you cannot have a conversation without talking about. And the way we always like to talk about it is let's talk about tools and jobs. This is another form of tool, and it is going to make everyone more productive. It's going to allow us to produce more, which is exactly what we need, especially at this time. And I think you can take that to a philosophy as well, right? Like if you think about it, what's better for us as a company to allow people to produce, twice as much, and then go on to doing other things and give these tools to more and more people? Or is it better for us to, eliminate a person, but really just do one thing super well? And the best thing is we can actually produce more by getting this in the hands of more people and not really trying to do every little part of the job. And we see, you can imagine very quickly, we could get to doing 70% of the drywall finish. And then it's much better for us to go start working on paint than it is to think about like, hey, let's eliminate a person completely from finishing type of thing.
That's interesting. That's a very interesting. Is that something that you learned during the process? Like when you started the company, was your initial goal to automate the entire thing, but then reality set in and job site conditions set in, and you learned that it's far better to just automate 70% or 80% of the process with a machine?
Well, I think I came in with the mindset as opposed to learned it along the way, because I'd stubbed my toe so much on trying to make robots work in the past and understood kind of that really you're talking about where do you draw your strengths from, and people have amazing strengths in handling all the variation out there and adapting, and so you pair the strengths of two things together and it just makes it that much more powerful. And so that's a philosophy we really came in with when we started the company. And it's it's in our mission statement and our value statement. Like our vision is to enable people to build in bold new ways. Doesn't say anything about automation. And we define ourselves as a technology company focused on improving the affordability and quality of the places we work and live, while improving the working conditions for those who are building them. So again, we don't really talk about automation as our goal. We talk about kind of like, what do we really want to create in the world?
So that's very interesting, because when I went to your website and I was looking at your mission statement, it didn't specifically talk about a drywall robot. It was a little more vague. It was a little like broader vision. So do you have future plans to build other robots under canvas construction?
Absolutely. Yeah. I mean, we very much expect to be a technology company. And in fact, we'll start by building more applications on this platform. Like I mentioned, paint is kind of obvious once you're doing the finish. There's a lot of other labor intensive needs that if you can have a mobile system that can put a tool in its hand under the guise of a worker, you can speed up a lot of different parts of the site. We're not talking about which ones of those are, because we're really focused on finishing right now and want to make that successful on its own. But there's a huge amount of opportunity. And so that's what we'll do as a company. And you're exactly right. We were very specific about that. Because the other mentality we want to create is never to be satisfied with what we've already created ourselves. We also want to be the person that builds in bold new ways and realize what makes our system obsolete and build that thing. So that's all part of kind of our culture.
So right now I'm envisioning your robot as kind of a good old-fashioned drill, where you can change the bit for different purposes. So you have one bit for spraying drywall finish, you have the next bit on for sanding, and then another bit that comes on for texturing, or another one that comes on for painting. But it's this one solid core that can be adapted for different purposes.
Yeah, that's exactly right. And that's how we see the world. And so, drywall finishing just happens to be one of the biggest pain points. And that's why we started there.
So what other plans do you have for the rest of this year?
I mean, the big plan for the rest of this year is, I just mentioned that launch of our level 4 system, enabling us to do both level 4 and level 5 and speed up, which gives us access to getting this machine into the hands of so many more people than we were doing before. And that's the goal right now, is training up certified finishers out there, enabling them with a new set of skills and getting machines out on projects.
That's very exciting. Well, Thank you, Kevin. I really appreciate it. Thanks for sharing all that information with us and telling us how your robot works. I'm looking forward to seeing that being used on homes very, very soon.
Your home, no doubt.
No, yes, absolutely.
Yeah, you and me both. I'm excited to have a machine to help me with the finish of my basement as well.
Yeah. Well, thanks, Kevin. And I'll link your website and your Instagram page and all that in the description. If people want to know more about your robot, what's the best way to contact you all?
Check out the website. We are canvas.build. There's no .com on the end. And you can get a hold of us. There's a form that if you've got something you want to do with the robot, just let us know and we'll make sure to respond to you. We're getting a lot of inbound right now and trying to make sure we can get to everyone. Yeah, please come contact us.
Thank you, Kevin. Appreciate it.
All right. Thank you, Belinda. It's been a pleasure.